Hello students, today we are going to study about your strength of acid and basic solution. We will study about pH scale. Earlier we studied various indicators, some natural and few your artificial indicators, with the help of which we can find out about as presence of acid or a base. But there is a limitation. Firstly, these indicators sometimes they either represent an acid or a base, and there is confusion regarding your acidic, basic, and neutral solution, and they do not tell us about the strength of your acid or a base. Let me explain using an example. We all know that turmeric is a natural indicator, and when we use turmeric, it turns red in presence of a base, but it doesn't change its color in presence of an acid or neutral substance. So there is a confusion to find those things. Secondly, if we are using soap, which is a mild base, or your sodium hydroxide, which is very strong base, but the turmeric indicator will not tell us the difference between the two. So that is the thing with these indicators. Now, pH scale is a universal scale, it's a universal indicator. It means that we can find out about all the things using the pH scale. We can find their acidic, basic, or neutral nature. Not only this, we can find their strength. So, students, in 1909, Sorensen devised a scale known as pH scale, on which the strength of acidic solution as well as basic solution could be represented by making use of hydrogen ion concentration in them. The pH scale or the pH of a solution is inversely proportional to the concentration of hydrogen ion in it. It means that higher the concentration of your hydrogen ion, lower will be the value of pH. We know that when an acid is placed into water, when we dilute an acid, during the process of dilution, an acid releases H positive ion. If your acid is releasing more H positive ion, it means that your acid is very strong. And if your acid is very strong, then it will be having a very low pH value. Now it must be clear to you, students. Now we are looking some more things here. The term pH, in the term pH, the P word, letter P, is from a German word Potenz, which means power. And the H is for your hydrogen ion concentration. So the strength of acid or base measured on a pH scale represents the concentration of H positive ion in your solution. Now, pH scale has value from 0 to 14, and it is just a number, it's not having any unit. We are having three kind of substances depending on their nature. We say them acidic, basic, and neutral. So students, on pH scale, your neutral substances will be having pH exactly 7. So pure water, which we say distilled water, is neutral, neither acidic nor basic, and it's having pH 7. Secondly, acids. Acids have pH value less than 7. Okay, lower the value of pH, stronger is the acid. Now, bases having pH value more than 7, they are in the range of 7 to 14. So higher the pH value, stronger will be the base or alkali. Now students, we are comparing acids and bases depending on the pH value. In the first picture, students, you can see that here hydrochloric acid, which is a strong acid, is having pH value 1. Second, acetic acid, which is a weak acid, is having pH value 4. It means that higher the value of pH, your acid going to be a weaker. Now, for bases, First is your magnesium hydroxide, which is a weak base and we better know it as milk of magnesia, having pH value 10. Second is your sodium hydroxide, which is a strong base, is having pH 14. So for bases, higher the pH value, stronger will be the base. So this was the concept which we have to understand. Now let's see the pH scale. As I said, students, pH is having value from 0 to 14 and your neutral things are at 7. And this 0 to 7, this is the range for acids, and your 7 to 14, this is the range for bases. Your weak acid are in about this range, and this range is for your strong acid. Similarly, weak bases are from 7 to 10, and beyond that you find your strong bases. Now, as the H positive ion concentration increases, your acidic character also increases and the value of pH decreases. For bases, students, your OH negative ion concentration is increasing in this direction and H positive ion concentration is decreasing. Even bases are having H positive ion but very less, because your pH scale going to measure H positive ion concentration. So here in the direction of bases, H positive ion concentration is decreasing and OH negative ion is increasing. Now depending on this you are getting pH value more. Now you must have understood it. pH scale, we are comparing it using your color. Actually, when you dip a substance in using a pH paper, when you dip a pH paper in a substance, then you get variety of colors. So these are the colors. You get some shades of red too, some shades of blue, and you get green and other things. Now if a substance is having pH value 0, you will get dark red color. For 1 red, 2 red, 3 orange red mixed color. For 4 you will get orange. Then for 5 orange yellow. For 6 greenish yellow. For 7 green. For 8 greenish blue. For 9 blue. For 10 navy blue. For 11 purple. For 12 dark purple. For 13 violet, and 14 violet. So this is a way we can, this is the way we can find out that your acid or base of what color it's getting and what is its strength. So pH scale help us to find out both the things, whether a particular substance is acid or base or neutral, and secondly whether your substance, what is the strength of your acid, base or neutral thing which is you are testing. So students, today we studied about pH scale and you must have understood it. That's all students, keep learning.